All right, this question's essentially a completing the square question, and I quite like to do it this way. I'm going to make a square. I'm going to try and fit x squared minus 8x plus 25 into it. The first thing I'm going to do is put an x here and here because I know the sides have to be the same length, so I need an x here and here. And I've dealt with the x squared because this would give me x squared. What next? I want my minus 8x, and I want the sides to be the same. So how can I get that? Well, I can get a minus 4x here and a minus 4x here if I put minus 4 here. So I'm basically halving the minus 8x into minus 4x and then putting it on both sides. That leaves us necessarily 16 here. And what I've done is I've shown that x squared minus 8x is equal to x minus 4 squared, this square, but I've got this extra term. So I'd actually have to minus the 16 from the square to get back to the x squared minus 8x. Now, if you expanded this out, you'd see it works in the same way. If you expand this double bracket, you get x squared minus 8x plus 16. So again, you can see that you need the minus 16 for it to cancel. So we're nearly done, and I've done that quite quickly, but I hope that makes sense. People tend to kind of learn to just have whatever's here and then minus this thing squared, and that's fine, but like you might just forget why you're doing that and you're not really demonstrating your understanding. So if I want x squared minus 8x plus 25, then it's going to equal x minus 4 squared minus 16 because that's what this bit is. But then I need to add on my 25 still, and so my final answer will be x minus 4 squared, and then this is going to become plus 9. And now I've got it in the completed square form that's been asked for. Why on earth would I want to do this? Well, it's actually really useful. It's useful for being able to solve quadratic equations, derive the quadratic formula, not something I'm going to do here, but it also gives us the turning points. Because if I want to find the turning point, let's just recap what that is. So this is a quadratic graph. It's a smiley quadratic graph. It goes through at 20 when the intercept is 25. So maybe it looks a bit like this. It's only a bit of a rough sketch, but at some point it turns. It has its lowest value. Now, where does it have its lowest value? Very tough to look at this and figure it out. Actually, with some practice, very easy to do it from here because this term is always greater or equal to 0. It can't possibly be negative. So the lowest it can be is 0, and that will result in the lowest point on the graph. So the lowest it can be is 0. The lowest the whole thing can be is 9, and that will be our y value that goes there. What makes this thing 0? Well, it's going to be when x is 4. So I essentially take the negative of whatever in here, take this one here, and that gives me my turning point. But I've tried to explain why that is. All right, and then finally, hence described a single transformation which maps the graph x squared onto the graph of x squared minus 8x plus 25. Oh, cheeky. Okay, I know what to do here. So we can write that x squared, y equals x squared is transforming to this thing here, which is actually y equals x minus 4 squared plus 9. Now this is not an easy question in my opinion, because actually when you cover this in A level, you sort of treat the transformations. You learn about this, what adding 9 does, and you learn about what minusing 4 does within the x. But essentially, let's do it in 2 stages because I think it will just make more sense. If I was to write y equals x minus 4 squared by itself, then what this actually does is I shouldn't say shift, it translates the graph 4 units to the right, in fact, not to the left, but to the right in the positive direction, because y equals x squared is here, whereas the roots for this one will be 4, and it will end up over here. So this is a translation by 4 units in the x direction with a negative there. But if I was to do y equals x squared plus 9, then in fact, that would also be a positive translation because it would jump up by 9. Whatever my y value was, I'm going to add 9 to it. So this is also a positive translation. And just to get to the point, my answer, in fact, is translates by, but I don't want to say 4. I suppose I could say 4 units in the x direction and 4 units and 9 units in the y direction, but what I think they're looking for is a vector to indicate movement. So it translates by 4, 9. That is a single transformation. I just happen to be moving to the right and up. That's absolutely fine. And I'm just trying to explain again why the -4 leads to 4, but the 9 leads to 9. It's just an interesting, well, not interesting. It does. You have to kind of get into the depths of transformations to get your head around it to some extent. But I have at least explained it using graphs. I don't think I'm going to talk about any more here. It's something I go into more detail in A level. But anyway, that's the answer. Be aware that, yeah, it's another use of completed square form, and we're adding 9 to our values, but we're actually going to be shifting the graph to the right as well.